Okay, so this is the third of the lectures in the indices series. In the first lecture of this series, we had done the theory of indices. We had studied these laws. In the second lecture, we did question number 1. If you saw these two videos, you would have seen that the quality of questions that we did was pretty good. So this video is good for you if you are from ICSE board, if you are from CBSE board, and even if you are preparing for any competitions like SAT or Olympiad or MBA or any other question, any other competition. Okay, the question that I'm doing, they are taken from SELINA 2020 edition. SELINA is a textbook for ICSE. This is exercise 7A. Second video we have done question number 1. In this video, we'll be doing question number 2 and question number 3. Let's start. So the second question is simplify 8x cube divided by 125 y cube 2 by 3. You can note down this question and we will start this question on the other screen. So 8x cube divided by 125 y cube whole raised to power 2 by 3. I can write this as 8x cube upon 125 y cube whole power 2 by 3. I can write this as 2 cube. This is already x cube. 125 can be written as 5 cube. Y cube is already y cube whole power 2 by 3. Now let us have a look at this rule that we have been looking at time and again, that a raised to power m whole power n can be written as a raised to power m into n. So have a look at this rule and also have a look at this rule, that a into b whole power m is equal to a raised to power m into b raised to power m, and this rule a upon b whole power m is equal to a raised to power m upon b raised to power m. So if you are not clear about these rules, again I'm requesting you to have a look at the first lecture at least. If you are okay with these rules, then we can start with the question. Okay, so this 2 by 3 would come and meet this 3, this 3, this 3, as well as this 3. So I'll write whole of this as 2 cube into 2 by 3 into x cube into 2 by 3, 5 cube into 2 by 3, and y cube into 2 by 3. Okay, now as you can see that this 3, 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 this 3 cancels off. I have 2 square upon x square upon 5 square into y square. This is equal to 4x square upon 25 y square. This is the final answer. Okay, let's move on to the next question. You can note down this question and we'll start this question on the next screen. Okay, so this I can write as, see, this is 2 raised to power minus 1. This I can write as 1 upon 2. So this is equal to 1 upon a plus b. Again, if you want to see the rule that I'm applying, you can have a look at this sheet here. This is where it is written, a raised to power minus n is equal to 1 upon a raised to power n. So this is the rule that I'm applying here. Okay, into this is 1 upon a plus 1 upon b. Okay, so this is 1 upon a plus b into LCM would be ab, and I'll be getting b plus a here. And I hope you can see here that a plus b and b plus a will cancel each other. Why? If there is a confusion, you can write this as a plus b, you can write this as a plus b, you can write this as ab. Now this and this will cancel. The final answer would be 1 upon ab. This is the answer. Okay, let's move to the third question. Okay, this seems to be a bit complicated. So this is 5 raised to power n plus 3. 5 raised to power n plus 3 minus 6 into 5 raised to power n plus 1. 9 into 5 raised to power n minus 5n into 2 square. Okay, so in all these questions, the basic thing that you need to understand is BODMAS. Always remember, when you have this sign as well as this sign, this sign, this sign, this sign, they are competing with each other. Always remember BODMAS. So as per BODMAS, multiplication will be given priority, then subtraction. So what I'm trying to tell you is that this multiplication would be prioritized upon this subtraction. So this will be taken as one part. Similarly, this multiplication will have a priority on this subtraction. This multiplication have a priority on this subtraction. So this will be considered to be one part. This will be considered to be one part. And of course, this is one part. So this should be your fundamental approach when you are solving these questions. So please note this question down, and we'll start on the next screen. Okay. So this is one part. This is one part. This is the second part. This is the third part. This is the fourth part. Now what I'll do is I'll write this 5n plus 3 as 5n plus 1 into 5 square minus 6 into 5 raised to power n plus 1 whole upon. Now if you look at this, you can see that this 5n and this 5n can be taken outside. This is common, and I'll remain with 9 minus 2 square. 2 square is 4. I hope you get this. So I can write this as, see, this is 5 raised to power n plus 1 into 5 square. So this can be written as 5 raised to power n plus 1 plus 2 is equal to 5 raised to power n plus 3. This 5 raised to power n plus 3 is this 5 raised to power n plus 3. And which rule have we applied? We have applied this rule. A raised to power m into a raised to power n is equal to a raised to power m plus n. You need to be very clear about the rules of indices. Otherwise, these questions become a headache. So now I'll take this and this common. Okay, when I take it as common, so I have 5 raised to power n plus 1. This is 5 square. 5 square is 25 minus 6 whole upon 5 raised to power n into 5. So this is 5 raised to power n. 25 minus 6 is 19 upon 5 raised to power n 5. This would be equal to 5 raised to power, this is n plus 1 minus n. So this would be 5 into 19 upon 5. So the final answer would be 19. This is the final answer. Let's move on to the next question. Please note down this question so that we can start. Okay. So what I'll do is I'll apply a raised to power b, a raised to power minus b is equal to 1 upon a raised to power b rule here. This rule is nothing but 2 raised to power minus 1 is equal to 1 upon 2. So this negative actually makes this number go into the reciprocal mode. So this would be equal to 1 upon 3x square whole cube into x raised to power 9 into 2 by 3. Now this 3, when it comes inside this bracket, it will meet both this 3 as well as this 2. So this will be equal to 1 upon 3 cube x6 into x raised to power 6. So this and this will get cancelled. The final answer that we will get is 1 upon 27. I hope it is clear. See, all these questions are very good to practice. And that is why I told in the beginning of this video that even if you are from other boards or maybe even other classes, if you want to do indices in detail, the quality of questions is very good. Can be used for competitions also. So for example, if you are preparing for Olympiad also, these are excellent practice questions. Okay, so next, let's move on to the next question. 1 upon root 4 plus 0.01 raised to power minus half minus 27 raised to power 2 by 3. If you are following the lectures, then you would be knowing that I'll be reducing this 47 to 3 cube. I'll be reducing this to 10 square. I'll be using this negative to make a reciprocal of this number. This is pretty obvious. This is 1 upon 4. Root 1 upon 4 would be equal to 1 by 2. So let's do this on the next screen. So I can write this as root 1 upon root 4. I can use this negative to make a reciprocal of this number. And this I'll write as 3 cube. And 2 by 3 is waiting outside. Okay. Root 1 is 1. Root 4 is 2 plus 1 upon 0.01. 0.01 is equal to 1 upon 100. Is equal to 1 upon 10 square. Is equal to 1 upon 10 square. Is equal to 10 raised to power minus 2. You should be pretty clear about this. But here what I'll do is I'll reduce this 0.01 to this 1 upon 10 square. Sorry. 1 second. This 0.01 to 10 raised to power minus 2. This is what I'll be using. So this 0.01 I'll be writing as 10 raised to power minus 2 half minus. See, now this 3 will be multiplied by this 2 by 3. And you'll see that this 3 and this 3 will get cancelled. So I'll have 3 square only. So this whole is equal to half. Now let us look at this. This 2 and this 2 will get cancelled. This whole of this term is equal to 10 raised to power minus 1. And so I can write this as 1 upon 10 raised to power minus 1. And this is 3 raised to power 2 is 9. So this is half plus 10 minus 9. Why 10? Because this is 1 upon 10 raised to power minus 1. So 10 minus 9 is 1. 1 plus half is 3 by 2. 3 by 2 is the final answer. Let's see the next question. Next question. 27 by 8. Again, the same argument. This I'll write as 3 cube. This I'll write as 2 cube. There is a 2 by 3 waiting outside. Minus 1 upon 4 raised to power minus 2. I'll use this minus and take a reciprocal of whole of this term. Plus 5 raised to power 0. It is obvious that 5 raised to power 0 is 1. You can note this, pause the video, have your own solution and check with my solution. Let's start. So as I told you, 27 is equal to 3 cube, 8 is equal to 2 cube, 2 by 3 is waiting outside, minus 1 upon 4 raised to power minus 2, 5 raised to power 0 is 1. So this would be equal to 3 raised to power 3 into 2 by 3. This 3 will get multiplied by 2 by 3 minus. I'll use this negative to take a reciprocal of whole of this number. Whole of this number, reciprocal is 4. And there will be a 2 outside. And there is 1. This gets cancelled. We have 3 square. This would be equal to, this whole would be equal to 3 square or 9. This would be equal to 2 square or 4. So this is 9 upon 4 minus 16 plus 1. Whatever is your answer is your final answer. Okay, so the answer is minus 51 by 4. I've taken a LCM of this number. This is the final answer. Hope you also got this number. Okay, so we'll do the next questions, question number 4, question number 5 and question number 6 in the next video. I hope you liked the video. Hope it was useful to you. See you next time. Thank you.